Hey, this is Alex Panner, Physics 2211, Section M08. This is Lab 3, Constant Velocity Motion. And I observed rolling a basketball on the court, and the main result is that when we apply the momentum principle, which is Newton's second law, then if the net force is equal to 0, then a model can provide a good prediction of the observed motion. So now for the video, the total length of the video was about 3 seconds, and we're going to look at half a second of the ball rolling. And in this time there's 15 frames, and each frame is a 30th of a second. And you can see the ball starts out at the origin, and it is going to go in the positive x direction. And I track the motion using the center of mass of the ball. And I use the calibration stick here as the diameter of the ball, which is 0.2385 meters, which I looked up. And from this data analysis, from the points, we get a graph, which we can see here. And this is the x-axis is time, and the y-axis is the position along the x-axis, and you can see that it is going in the positive x direction as time increases, and it is at a constant rate because the function is linear. So now, using this, we wanted to make a model using VPython. And so for some of the initial conditions, the mass of the ball is 0.608 kilograms, and the initial position, which we see here, started out at the origin, and the ball's velocity, which there were two ways that I kind of looked at calculating it, and one was using the change in position over change in time, or you could use the slope of the line of best fit, and I chose the line of best fit because it's more like a derivative, because it breaks the components into small time intervals, which were the picture frames. And then the time step is 0.01, which is fairly small compared to the time interval we're looking at. And here it was for 0.5 seconds, half a second, and the net force was 0, which we see here in Newton's second law. Since the force is 0, then this whole part of the equation cancels out, so the ball's velocity remains constant. And then we use that to predict the ball's position over the time interval. So let's see. So when we run the program, this is what it looks like, and you can see that the ball moves to the right, or the positive x direction, and you can see that is also reflected in the graph. So then from VPython we extracted that data, and what we get when we compare the two. And here you can see the red is the model, and the blue in the background, which you can barely see, is the actual position of the ball. And they're both plotted in the time versus the position on the x-axis, and the velocity was approximately 1.615 meters per second. And we see that it was a pretty good experiment because the model is almost exactly, it all fits almost perfectly with the actual data results. And so our what if question is, what if the ball moved in the negative x direction? And all that changes is the velocity is negative because it's going in the negative direction. So here you can see the ball moves to the left in the negative direction, and that is also reflected in the graph, and it's moving in the negative direction. So what does this all mean? So our net force was equal to 0, which means that all the forces that are acting, all the external forces that are acting on the ball, they all cancel out. For example, like the force of gravity is canceled out by the floor pushing up on the ball. And when we observe Newton's first law, it says that an object in motion wants to stay in motion. So the model was a pretty good fit.